For years, astronomers have dreamed of seeing another world the way we see our own. Clearly, directly, undeniably real. Not a blurred signal, not a distant shadow, not a simulation stitched together from data, but an actual image of a planet orbiting another star. A world with its own sky, its own atmosphere, its own story. And now, for the first time in human history, the James Webb Space Telescope has done exactly that. It has captured the first real image of another world, a world that shouldn't exist where it is, a world stranger than anything we imagined, and a world that is already rewriting the rules of planetary science. But this image was only the beginning, because as James Webb Telescope continued observing, it uncovered something even more shocking. Other planets with impossible chemistry, mysterious atmospheres, broken rules of formation, and one that may even hold the strongest hints of alien life we've ever detected. Tonight we're going to step into that first image and follow the trail of discoveries it unleashed. K218b was never meant to be the center of global scientific debate. At first, it was just another distant super-Earth, too large, too far, too difficult to study with the instruments we had at the time. But when Webb pointed toward it, the telescope didn't just collect data, it peeled back the atmosphere itself. Layer by layer, molecule by molecule, the James Webb Telescope revealed a world wrapped in a dense envelope of hydrogen, beneath which may lie something extraordinary. A global ocean deep enough to swallow mountains whole. Water vapor appeared immediately, strong, unmistakable. But what came next pushed this planet into scientific history. Webb detected methane, carbon dioxide, and then the molecule that sent shockwaves through every observatory, dimethyl sulfide, a chemical that on Earth originates almost exclusively from life in our oceans. This wasn't noise, it wasn't distortion. It repeated across multiple observations. Suddenly the idea of a dark, endless alien ocean didn't seem fictional, it seemed probable. A world where sunlight filters weakly through a thick atmosphere, warming the boundary between day and night into a stable, habitable twilight. A world where life, if it exists, could rise slowly and silently, forming ecosystems unlike anything on Earth yet governed by the same universal chemistry. Scientists didn't want to say it, but they had to admit it. If any planet we've ever studied can host life, K218b may be the first real contender. When Webb captured the first real image of HIP 65426b, astronomers expected a typical gas giant, massive, distant, and predictable. But the image revealed something far stranger. HIP 65426b is a colossal planet nearly 7 times the mass of Jupiter, orbiting so far from its star that it shouldn't exist at all. According to every planetary formation model we have, giants this large must grow inside the swirling disk of dust and gas that surrounds a young star. But this world sits far beyond that region, alone in the darkness, as if it formed in a completely different place and arrived later. The mystery deepened when the James Webb Telescope analyzed its light. Instead of the smooth atmospheric profile expected from a gas giant, HIP 65426b displayed unexpected chemical layers, strange variations in temperature, and cloud structures that defied stability. The atmosphere didn't behave like a planet peacefully evolving in a star's orbit. It behaved like something unsettled, something that had experienced violent changes or had traveled across different environments before reaching its current position. This led scientists to propose theories that once seemed unthinkable. Perhaps the planet was ejected from another star system during a chaotic collision and later captured by its current host. Or maybe it formed alone in the cold darkness of interstellar space, a rogue planet, wandering for millions of years until gravity finally claimed it. But the most intriguing possibility is the one astronomers whisper more than they admit, that HIP 65426b isn't just an anomaly, it's a clue. A sign that solar systems may form in ways we've never imagined, that planets can migrate enormous distances, and that the universe is capable of assembling worlds through mechanisms we haven't even begun to understand. Webb's first real exoplanet portrait wasn't simply proof that other worlds exist. It was a message. These worlds are stranger than anything we expected, and the next ones would push the mystery even further. Proxima b has been called the most tempting planet in the galaxy. At just over 4 light-years away, it sits in the habitable zone of Proxima Centauri, the closest star to our Sun. From the moment it was discovered, astronomers imagined oceans, atmospheres, and maybe even the faint silhouettes of continents beneath alien clouds. It was everything we hoped to find in an exoplanet, close, rocky, and sitting in the perfect temperature range for liquid water. But when the James Webb Telescope turned its gaze toward this nearby world, the excitement quickly became frustration. Proxima b orbits too close to its star, so close that the planet disappears into the glare, making its atmosphere impossible to observe directly. James Webb Telescope cannot separate the light reflected by the planet from the violent radiation of its parent star, leaving us with a world we can detect, but not truly see. And then, a deeper problem emerged. Proxima Centauri is not a calm star. It's a red dwarf prone to massive solar flares, bursts of radiation so intense they could strip a planet's atmosphere in a geological heartbeat. If Proxima b once had oceans or a breathable sky, they may have been blasted away long ago. Or worse, the planet could be locked in a permanent twilight, one side scorched and the other frozen, clinging to habitability only in a thin band between day and night. This paradox is what makes Proxima b one of the most haunting discoveries Webb has revisited. It is the world closest to us, the one we dream of visiting, the first destination in any future interstellar mission. Yet it may be forever beyond our reach and understanding. We can detect its presence, measure its gravity, sense its temperature, but its mysteries remain concealed behind the blinding fury of its star. Proxima b reminds us of something humbling. Even the nearest alien worlds can remain hidden, and sometimes the planets full of life aren't the ones closest to home. When James Webb observed WASP 39b, astronomers expected the usual profile of a hot Jupiter, a massive gas giant so close to its star that its atmosphere is stretched and boiling. But instead of simplicity, Webb uncovered one of the most complex atmospheric signatures ever recorded. Its skies contain water vapor, sodium, potassium, carbon monoxide, methane, and even sulfur dioxide, a molecule formed through chemical reactions triggered by stellar radiation. This was shocking because such reactions were only theoretical. No telescope had ever seen them happening on another world. Webb had captured the first evidence of active photochemistry in an alien atmosphere, chemical processes identical to those shaping Earth's ozone layer, but occurring on a planet hotter than a furnace. Even stranger, the ratios of these molecules didn't match any model. WASP 39b's atmosphere behaves like a laboratory of alien chemistry, full of reactions we don't fully understand and patterns we can't yet explain. This discovery changed everything. It proved that even the most extreme worlds can host complex, evolving atmospheres, and that the chemistry of the cosmos is far richer and far more unpredictable than we ever imagined. For years, TRAPPIST-1 was considered the crown jewel of exoplanet discoveries, a system of 7 Earth-sized worlds, several of them orbiting comfortably inside the habitable zone. It was the closest thing we'd ever found to a miniature version of our own solar system, and some believed at least one of its planets would reveal signs of life once Webb examined them. But when the telescope finally analyzed the first 2 worlds, the results were devastating. There was no atmosphere at all. Not a thin layer, not a trace, not even the faintest whisper of gases clinging to their surfaces. Just bare, exposed rock constantly bombarded by violent radiation from their ultra-cool dwarf star. Without an atmosphere, these planets cannot retain heat, cannot shield themselves, and cannot sustain the chemistry needed for life. The dream of TRAPPIST-1 faded almost instantly. A system once thought to be a galactic oasis revealed itself as a chain of sterile worlds. And yet, this disappointment became one of James Webb's most important lessons. Habitability is far rarer than we imagined, and even a system that looks perfect from afar can hide a harsh and lifeless reality. As James Webb continued surveying distant systems, one truth became impossible to ignore. The galaxy is overflowing with planets. Big ones, small ones, frozen ones, scorched ones, oceans of worlds scattered across every arm of the Milky Way. And yet, despite this abundance, none of them have revealed clear, undeniable signs of life. We find atmospheres, storms, oceans, chemistry, and even conditions that resemble early Earth. But no confirmed signal of biology. This contrast is unsettling. Statistically, life should be everywhere, but observationally it remains silent. Either life is incredibly rare, hiding in forms we don't yet understand, or the universe is far more selective than we ever imagined. Webb's discoveries remind us that having the right ingredients doesn't guarantee life. Many planets seem almost habitable, almost Earth-like, almost familiar, yet fall just short. And with every new world we examine, the paradox grows deeper. The universe is full of places where life could exist, but none where it undeniably does. All of James Webb's discoveries point toward a profound truth. The universe is far stranger, richer, and more unpredictable than we ever imagined. We have seen oceans wrapped in hydrogen skies, giant worlds drifting where physics says they shouldn't, nearby planets hiding behind the fury of their stars, and atmospheres so complex they rewrite the rules of chemistry. We've watched our greatest hopes, like TRAPPIST-1, crumble under the harsh clarity of real data. And we've witnessed the unsettling silence of a galaxy overflowing with planets yet offering no clear sign of life. But for the first time in human history, we are not imagining these worlds. We are seeing them. Webb has opened a new window on the cosmos, revealing planets not as theories or distant signals but as real places, with real atmospheres and real stories written into their light. Each discovery brings us closer to answering the oldest question humanity has ever asked: are we alone? And if these new worlds are any indication, the answer may be waiting just beyond the next star. What Webb has shown us is only the beginning. The next image, the next spectrum, the next unexpected signal. Any one of them could reshape our understanding of the universe forever. If you want to follow every new discovery, every strange world, and every breakthrough that brings us closer to finding life beyond Earth, make sure to subscribe, turn on notifications, and join us as we explore the universe, one planet at a time.